blast off.
Good afternoon, everyone. I'm Dan Curtin, the president of the Wisconsin chapter of the Chemical Coders. Welcome to the first webinar in CCAI's virtual chapter event series. We're excited to connect with everyone today from around the country and look forward to learning more from our industry peers throughout the next several months. Just so everyone is aware, all attendees are muted now. If you have questions during the presentation, please type them in the question and answer box that should be visible on the right side of your screen. Matt will address the questions at the end of the presentations, and I'll read them to him. Now let's get started with the presentation. I'd like to introduce our speaker, Matt Kirchner. Matt is the president of ATS LAB Midwest, a distributor of advanced manufacturing curriculum, e-training and training equipment, e-learning and training equipment. He was previously CEO and COO for 3 manufacturing companies, including AFR right here in Wisconsin. And during his tenure there, he was an active member of the Chemical Coders here in Wisconsin. Matt is well known to the coding industry and very experienced with manufacturing challenges. Matt, thanks for being here, and take it away.
All right. Well, thank you, Dan, so much for having me. It's such a pleasure to be back with all my good friends from the Chemical Coders Association, and great to see so many familiar names and faces. So really appreciate the opportunity to spend some time with all of you. Everybody take out a piece of paper and a pencil, or if you don't have that, then grab your phone and maybe go into the notes section of your phone. We're going to have a little bit of fun. I want you to start out by picking a number. Pick a number between 1 and 10. And write that number down. And now that you have that number down, we are going to multiply that number by 9. And now you have a new number. So whatever your number was, multiply it by 9, write down your new number. And now take the 2 digits of your new number and add them together. So if your new number is 13, 1 plus 3 is 4. If your new number is 32, 3 plus 2 is 5. So take those 2 digits of your number and add them together. And now I want you to take your new number, so you have a new number written down that you have after you added those 2 numbers together, and I want you to subtract the number 5 from that number and write down your new number. Now we are going to pick the corresponding letter of the alphabet for your number. So if your new number, the number you have written down now at the very end is 1, you're going to put down A, 2 is B, 3 is C, 4 is D, 5 is E, and so on. And now think of a country that starts with your letter and write down that country. And now think of an animal that starts with the second letter of your country. So take your country, find its second letter. Think of an animal that starts with that letter. And finally, I want you to write down the color of that animal. So look at what you have there. And I want to assure everybody that there are no gray elephants in Denmark. Yes, it is possible for us to use data to predict the future, and that is what we are going to talk about on today's webinar. So this will be fascinating to our friends. By the way, wait until later to figure out how I did that. This is really, really important. So turn your piece of paper over. You can figure that out later. And let's think about this. Let's think about how coding's technology is changing. Not long ago, I saw a presentation that looks like what you see on your screen. It's basically a paint robot painting a fuel tank, as you can tell. And that was a really, really cool thing for me to see. But I was talking to the engineer that put this display together, and he said, you know, if you think that's cool, come across the hallway. And he took me across the hall, and this is what was running across the hall. A full digital twin of that coding's operation. Now, here's why that is important to our discussion today. When we think about improving our production lines, when we think about improving our production processes, our coding's processes, we used to have to go out on the line and do that right out on the shop floor. Well, today what we can do is take that technology and load it up with smart sensors and smart devices that are gathering data in real time about force and temperature and disturbances and yield and all this other information. And then we build our digital twin. And now when we want to improve our process, we don't improve what's going on the shop floor initially. We improve it on the digital twin and experiment over and over and over. And folks, this is not technology that we're talking about that'll be available in the next 20 years. It's available today. There are companies doing this today. And there will be a huge gap between the companies that figure out how to do this and the ones that don't. And we're going to spend some time discussing that. Again, it's so great to be back with all of you. As Dan mentioned in that introduction, I spent a tremendous amount of time in the coatings industry, 17 years altogether, between ABQC and American Finishing Resources, and then once Du Bois Chemicals acquired American Finishing, working for them for a period of time. Chief executive, chief operating officer of several manufacturing companies over 20 some years in manufacturing. At the beginning of this year, we also launched the Tech Ed podcast. So this has been an absolute blast. You can find that at techedpodcast.com or follow it on Spotify, Apple, wherever you get your podcasts. We are interviewing some of the most interesting people in the world of advanced manufacturing and education. The CEOs of Fanuc and Rockwell Automation have appeared on that podcast. The founder of Ashley Furniture has appeared on the podcast. The president of Ivy Tech, former lieutenant governor of the state of Indiana, one of the founders of WebMD, the executive vice president of Haribo, the CEO and chairman of Snap-on. This week, we just released a podcast with former Wisconsin Governor Tommy Thompson, who is now the interim president of the University of Wisconsin System. So Tommy his podcast was released this week. We're having a ton of fun with that. Of course, I still do a tremendous amount of speaking, like this presentation I'm doing today. Still write the monthly leadership columns for Products Finishing Magazine and Production Machining Magazine. And also, as Dan mentioned, about 5 years ago, when I dedicated my career to securing the American dream for the next generation of STEM and manufacturing talent, my wife Renee and I acquired a company that is now called ATS Lab Midwest, and that is the largest distributor of technical education and industrial learning systems in the Midwest, and having a ton of fun with that. Fortunately, we have a great team of people that run that business for us day to day, which allows me to do things like this, which is my true passion, which is how do we secure the American dream for the next generation as technology changes like crazy. We are going to talk about that technology changing in this concept that I'm calling artifinishing intelligence. Yes, a cute little combination of the word finishing and the word artificial. But how are we as finishers, as coders, as platers, as suppliers to those folks, how are we going to adopt artificial intelligence in our organizations? There's 5 things that I think we want to remember, and we're going to cover all 5 of those today. The first one is we as manufacturers, we as coders must ignore the threat of this technology at our own peril. The truth of the matter is that large companies are implementing AI, implementing machine learning, implementing Industry 4.0 at an unprecedented rate. And when I talk to small to medium-sized businesses, most of them think it doesn't affect me. Well, believe me, it affects you, and we need to talk about that. So the first point is this: Google's CEO, look at this quote that he said. AI is probably the most important thing that humanity has ever worked on. He says it's something more profound than electricity or fire. That is how important Google's CEO says this is. Large Wisconsin companies are saying the same thing. My friend Bob Venable, President and Chief Operating Officer of Charter, talks about smart manufacturing and Industry 4.0 in his business planning. My friend Rick Anderson, Chairman and CEO of Smart Choice MRI, talks about machine learning and artificial intelligence in their business. The CEO of Sargento talks about using artificial intelligence for prediction. And my friend Mike Chico, President and CEO of Fanuc America, talks all about robotics, controls, and IIoT, all of them embedded with smart technology and artificial intelligence. Big companies are working on this like crazy. Why? Because they have vision. We have 2 types of companies when it comes to this type of technology. The first one are the companies with a limited amount of vision about this technology, about how things are changing. And then the other category are ones that have vision, and the ones that see the sea change that is coming. So the challenge is that these companies with limited vision tend to be a little bit apathetic about how this technology is affecting them. and the ones with vision. We've seen this film before, by the way, when standardized quality was a big deal several years ago. This goes back about 20 years when you think about ISO, QS, and TS. And that technology put a huge gap between those companies that had vision and the ones that didn't. And the people that implemented standardized quality started to get way ahead of the ones that did not. We saw the same thing when we had continuous improvement and lean and Kaizen, and we saw this sea change that took place in the early 2000s into the early teens, and it continues today. And companies that implemented Kaizen, implemented continuous improvement, started to gap everybody else. James, just as a quick programming note, I'm getting a little feedback. I wonder if maybe somebody isn't muted. Can you make sure all of our attendees are muted? Thank you. Much better. Sorry for that. So now when we think about what's happening in the future, we have companies that have no vision and companies that have vision. These big companies that see standardized quality and continuous improvement on the way, we are going to start to see smart technology and artificial intelligence creating that same kind of gap that standardized quality and continuous improvement did the last time around. This is coming. It's coming quickly. And we need to understand it because the companies that implement the technologies that we talk about today are the ones that are going to gap everybody else in the coming years. So, number one, ignore the threat at your own peril. I would be so bold to say that companies that don't implement some form of artificial intelligence don't understand how this technology is going to radically change our market. We'll talk about that a little bit later. Are at risk of not even being in business 10 years from now. It's that serious. But the opportunities are gigantic for the companies that figure this out. So the next question is, who is your artificial intelligence and data point person in your business? Think about what is that person's name? And if you can't think of who that person is, that might be part of the challenge. According to this amazing study that I read, 736-page report from the National Security Commission on Artificial Intelligence, just read this last week. They issued this report on artificial intelligence. This is the advice that they gave. This is the advice that they gave to federal agencies. Basically, appoint a full-time senior level responsible AI lead in every single department that is critical to national security in each branch of the armed services. They're saying that every single one of those agencies should have a single full-time person dedicated to AI. Folks, I am telling you that we should have exactly the same effort in manufacturing, that every one of our companies should have somebody dedicated to data, understanding data, and understanding how to implement artificial intelligence in our operations and our organizations. And we'll talk about that and how to do that here in just a minute. I want to start with this though. Who knows what a quant is? Is that a word that you're familiar with? AKA, what can hedge funds teach us about the future of manufacturing? We have these folks on Wall Street. They basically analyze financial markets using these complex mathematical and statistical models. That's in some ways what artificial intelligence is. They even have a school called the Stevens Institute of Technology in Hoboken, New Jersey that trains these people. And the truth of the matter is, as this young man, Dakota Wixom, a 22-year-old, says, the reason that some hedge funds are able to repeatedly beat their market averages is because they hire quants, programmers, and data scientists, people that are watching the data, people that are implementing AI, people that are predicting the future. And as my prediction in the future, if you know somebody who is smart and analytical and career undecided, huge opportunity for those people if they understand manufacturing and data analytics, building the tools that gather and analyze information and create actionable data. I have two kids. They're both in college now. My daughter is a freshman in the data science program at the University of Wisconsin, studying exactly this. So practicing what I preach, I strongly encourage her to consider that career choice, and that is the path that she's on, at least for the moment. The truth is there are amazing career opportunities for our young people and people of all ages. Look at this report that was done now. It's been about 2 years by Manpower and the DMDII. And these are the types of careers that are going to be available in manufacturing in the future. If you look down that list of bullet points, almost every one of them has a connection, and in some cases, a serious connection to artificial intelligence. And that is where our career opportunities are going. This is why it's so important that we start understanding the data that we have and using AI to benefit our operations and to improve our operations, because we will have career choices and we will have jobs and positions in our companies 5 and 10 years from now that most of us have never even heard of. That is where all of this is going. So who is your AI and data point person? If there isn't somebody on your team who's responsible for this, it's time to think about who should be and who could be, and adding that competency to your team so that we can get on with understanding our data, understanding what it's telling us, and making sure that we're using it for continuous improvement. And that is really our next point, is that artificial intelligence is a lean tool. That is how I think about this. And here's an example of that. I was sitting outside eating lunch in Chicago about a year and a half ago, and I was having lunch with a very good friend of mine by the name of John Lowry. Some of you may even know John. He ran the Harley Davidson plant in Kansas City for a number of years. He ran the powertrain plant in Milwaukee for a number of years. Fantastic guy. Was recently named the Assistant Secretary of Labor for the U.S. Department of Labor in the Trump administration. He was also, by the way, a guest on our podcast earlier this year. So if you're interested in what John sees happening in the world of manufacturing, that was an interesting podcast. But he and I were having lunch and talking about AI, talking about Industry 4.0. And John made this point to me. He said, it's not a step transformation. We don't become an artificially intelligent company. We don't become an Industry 4.0 company. It is a tool that we use to improve our operations. And that's how we have to think about artificial intelligence. I can tell you that Jay Lee, who is the vice chairman of Foxconn, building a huge operation in southeastern Wisconsin, and that is going to be just absolutely incredible what they're doing down there in Mount Pleasant, Wisconsin. But Jay Lee is the vice chairman of Foxconn, wrote a book called Industrial AI. And here's how he thinks about it. He said he's noticed that basically data scientists never start out by asking what problems we have. He said they basically come into the factory and what they first care about is what data we have. And he said they have it backwards. The truth of the matter is we should be finding the problems in our operations and then using artificial intelligence to solve those problems, to improve our operations. That's how this works. I had a meeting probably a year ago with the CEO of a huge American company. Every one of you would recognize the company, tens of billions of dollars in revenue. And he and I were chatting about this, and he told me a story, and I don't have his permission necessarily to share it, which is why I'm not sharing his name, but I don't think he would mind that I'm sharing the story. He mentioned that he had a team of data scientists that came to work in their organization for a period of 6 months. And they basically just let them loose, gave them all the data that they needed, access to all the information that they needed. He said 6 months later, they came into our boardroom and gave us this amazing presentation about all of this data that they had analyzed. And then he laughed and he said, but the sad thing was it had nothing to do with our business. So we couldn't use it to improve. We don't use artificial intelligence to improve the business in general. We don't set up an artificial intelligence strategy. We find problems in our business and then bring artificial intelligence, machine learning, Industry 4.0 technology to bear on solving that problem. So we have to think about AI as a lean tool in the same way that we would think about Six Sigma or Hoshin Kanri or Poka-yoke, error proofing. We have to think about AI as a tool that we use to improve our business, whether that's our operations, our customer experience, our employee relations, whatever. It's a tool we use to improve, and we have to have it in that context. So number 4, we need to know the language. We need to know the language of artificial intelligence. And so we're going to talk a little bit about some artificial intelligence terms and familiarize you with some things. But before we do that, I want to ask you this question. Who can tell me what is, and just answer in your head, what is opinion, age, shape, color, origin, material, purpose? The answer to that question is that is the order in which we, without even realizing we're doing it, place adjectives in front of a noun. Which is why I can say lovely little old rectangular green French silver whittling knife. And if you think about it, you can probably visualize what I'm saying. But if I say old little French whittling, lovely silver rectangular green knife, I sound like I'm crazy. It's why we can't say my Greek fat big wedding, or my walking leather brown boots, or green little men. It doesn't make any sense. So that is the order in which we place adjectives in front of a noun without even realizing we're doing it. How about what is IAO? Anybody know what IAO is? That is the order in which you place similar sounding words based upon the vowel in those words, which is why it's really hard for me to say mash, mish, chat, chit, dally, dilly, shally, shilly, top, tip, hop, hip, flop, flip, tack, tick, and dong, ding. But I can say mish, mash, chit, chat, dilly, dally, shilly, shally, tip, top, hip, hop, flip, flop, tick, tack, and ding, dong really, really easily. Now, we don't even realize we're doing it, but our brains do that. And that's when we think about artificial intelligence, what a challenge our data scientists have in making machines think like human beings. But I can tell you today, they are making tremendous amounts of progress. I want you to think about Waymo. If you know what Waymo is, that is the Google car. And this goes back to the end of 2017. They had reached 4 million miles of self-driving miles. And I've been watching this for a while. So then at the early 2018 stage, they had reached 7 million test miles. And then we got into mid 2018, 8 million test miles. And by early last year, 20 million miles on public roads. And now in the wake of COVID, they were doing hundreds of years of driving every single day on a simulator. And let me explain to you why I think that's important. Let's think about this little Google car that's driving around, self-driving car, and it's driving around looking at street signs, looking at whether something's a fire hydrant or a mailbox or a person, knowing where children are often likely to play, all this other information. It's gathering all this information and sending it up to the cloud. And the cloud is analyzing it and categorizing it and sending it back down to every single Google car. Now, at the same time, every other car is driving around experiencing the exact same things and sending that data up to the cloud and sending it back down to our Google car, all using artificial intelligence. Now, the reason this is important is that car gets smarter and smarter and smarter to the point where every single individual Google car has hundreds and hundreds and hundreds of years of driving experience. And that is the power of the cloud. That is the power of artificial intelligence. And this is just one application of it. So 8 AI terms every single finisher should know. Let's start out with what is artificial intelligence. According to Jay Lee, in his book, Industrial AI, he said it's really a combination of 6 fields. Natural language processing, so that's like the voice recognition on your phone. Computer vision, so think about a vision system on a robot or a vision system on a production line that is identifying parts, identifying rejects, and pulling rejected parts out of the population. Cognition and reasoning, this is essentially the way that we experience the world and the way that we think about the world. Game theory and ethics, game theory being the mathematical models that basically determine how rational people make decisions. And machine learning and robotics, machine learning is essentially a computer learning from its own experience and getting smarter and smarter over the course of time. My friend Murtaza Bora has some interesting input on artificial intelligence. I've gotten to know Murtaza pretty well. He spends a tremendous amount of time studying in this field. And he says artificial intelligence is this. He said if we start out with the word intelligence, intelligence is a combination of experience, which is our connections and our linkages between ideas, and learning, basically the process of increasing our own knowledge. So he starts out with that. He says intelligence is the combination of experience and learning. And then he says artificial intelligence is just a mathematical representation and an algorithmic implementation of intelligence. So that's really when, as complicated as we can make this, it's really a mathematical representation of our own experiences and learning. And that is a good way to think about artificial intelligence. Then we get into industrial AI. Is that different? Is artificial intelligence in the industrial world different? Well, Jay Lee says that it is. He says it's really the integration of people and things and systems all together. He uses the letters A, B, C, D, E, F to remember the combination of analytics, big data. We now have more data produced every year than in the last 5,000 years of human history. It's just absolutely incredible how much data we're producing. Computational platforms, we'll talk about those a little bit later. Domain knowledge, which is our understanding of manufacturing systems, powder coat systems, paint lines, those types of things. Evidence, so our experience in viewing and seeing what happens when we change variables on a manufacturing line and what that does to our yield, to our quality, to our throughput. And finally, feedback. So making sure that we have a complete closed loop as we're gathering information and evidence, that we're pumping that back into the model to improve our operations. So that is how Jay Lee differentiates industrial AI from just general artificial intelligence. What is an algorithm? We use that term a lot. This is a real easy one as well. It's basically the instructions and the rules that a computer uses to complete a task. If you think about it that way, it's a list of instructions, it's a set of rules that our computers are using to complete a task. That's all that is. An algorithm isn't any super, they can be super complicated, but they don't have to be. It's any list of instruction and rules that a computer uses to complete a task. That's an algorithm. So now we get into some interesting stuff. Classification and transfer learning. So here again, I owe my friends at Quanser for this video. They were on a webinar that I did with them not too long ago. This is really cool. This is using AlexNet, and it's basically a classification algorithm, classification software. So it looks at something and figures out what it was. I love the fact that it looks at that dog and first thinks that it's a Chihuahua, and then thinks maybe it's a llama, and then realizes that it's that's actually a Samoyed. But we can identify here in just a minute of a computer printer in the corner of the room. There it sees that. If we show it up with the window shade, it will tell us that it's a window shade. We can shoot it over at the espresso maker. It'll identify that, and then back to our dog. So that is classification software. And then we get into transfer learning, and I've got this video up for you just to show you a couple things. And we're going to be talking about some of these. That cue car that you see that it's identifying there, we're going to talk about in just a minute. But transfer learning essentially is machine learning that builds on previous information and builds on previous knowledge. As an example, if we teach a classification algorithm to classify types of cars, and then we want it to classify trucks, it will use what it already learned in classifying the cars in terms of classifying something similar. That's why we call it transfer learning. They're transferring the knowledge from one subject area to another subject area and continuing to build its own knowledge. Again, this is all happening with a computer learning on its own without somebody actually programming it or telling it. And this is technology that is alive and well today, believe it or not. So that's classification and transfer learning. Now we'll talk about supervised learning. And I'm running a little video over here. This is that cue car that we showed you just a minute ago. So we looked at the cue car not too long ago. This is a program that we're working on in the Detroit area, basically teaching students as young as the age of 12 about artificial intelligence, about all these things that we're learning here today, about how we code the algorithms that we use in machine learning and artificial intelligence, about all the technologies that are available to these students. So it's a really cool program that we're already working on. I've got several programs going at several universities as well, and at technical and community colleges. So really, we can teach this technology at every single level of education. But let's talk about what supervised learning is. So what you see over here on the left is a video, and that video is essentially that same cue car that we saw a moment ago, and it is being driven, if you will, by an individual. So somebody has a remote control. They are steering that on a 1/10 scale track in their office and driving that cue car around the office. Now, what's happening is that cue car is loaded up with a microprocessor, it's loaded up with LiDAR, it's loaded up with camera technology, and it's basically measuring the RGB, measuring the depth of the route that it's taking as the individual is steering it, and then comparing that route and comparing what it is learning to when the person steers. And literally, the AI on the cue car will learn how to drive itself. And so once it's done learning, we can take the remote control away and learning what it learned about what it was looking at, where the file cabinets were, where the line was, where the track was, where the people were. And we can take that now and use that same technology to have the car drive itself. And that is, there again, technology that's available now. And this is a demonstration of it that you see on your screen. So on the left, we have somebody driving the car. On the right, we have the car that took the information it learned through supervised learning. We gave it the answer. We want you to learn when to turn, and said, you figure out how to know when to do that. And the vehicle did that on its own. So that is supervised learning. Then we also have what we call unsupervised learning. So this is actually really cool. This is where we give basically give the system raw data, no labels, but we don't even tell it what the data is, what it represents, but it looks for patterns and information and correlations that were previously undetected by people and provides outputs and insights. So that's what we mean by unsupervised learning. Examples of that would be like the bank using data to do fraud detection. We used unsupervised learning in cracking the genetic code for COVID. And so that would be another example where we give it the raw data, and the unsupervised learning algorithms basically find correlations and find patterns that humans were unable to find. If you listen to Spotify like I do, and you're always amazed at how if you just kind of put it on autoplay, it will pick songs that typically you really, really like. That's unsupervised learning. It's taking a bunch of data from you and from everybody else and finding patterns in, if this person likes these songs and that person likes these songs, then they must like the same kind of music. Let's take person A's playlist and shoot some of those songs over to person B. That's unsupervised learning. That's an algorithm that is doing all of that. And we've got example after example after example of unsupervised learning as well. Finally, in terms of the terms that we should all know, this is reinforcement learning. So this is pretty cool. Another project I worked on with Quanzer. This is what we call a cube servo. So it's a servo motor. And what you see is what we want that servo to do is to stand that pendulum straight up. And so we tell it we want to stand straight up. And when we see actions we like, then we tell the algorithm we like that action, and we give it a quote reward. And if we see actions we don't like, then it doesn't get a reward. And over time, that algorithm will literally learn how to stand that pendulum up on its own and keep it there. And so that is, we didn't program that servo to do that. We told that we want that pendulum to stand straight up. You figure out how to do it. And the artificial intelligence on the cube servo figured out how to do it. So this is technology that we're using now, especially at the university level, to perform research and training and learning in the areas of artificial intelligence and machine learning. Okay, so those are our 8 AI terms every finisher should know. Artificial intelligence, how it differentiates from our industrial artificial intelligence, what's an algorithm, what are classification and transfer learning, what is supervised and unsupervised learning, and what is reinforcement learning. Now let's talk about how we are putting this stuff to work. And what we say is know the applications ×2, and that ×2 will become apparent here in just a couple minutes. So I love to tell the story in manufacturing of 15,000 robots. Right now, there is a company that has deployed 15,000 robots across its manufacturing operations. Paint robots, material handling robots, assembly robots. They've loaded those up with smart sensors and smart devices that are gathering data in real time about torque, temperature, disturbances, moisture, viscosity, sending that information to a computer network. From the computer network, it goes to a data collector, from the data collector to the cloud, where it's analyzed using artificial intelligence. Right now, today, that company has those robots to the point where they can predict their own future failure and order their own replacement parts before the failure ever happens. And I can tell you folks that we are seeing that technology not just on robots, but in machining centers and in warehousing and distribution, and yes, in metal finishing and coatings. That technology is on its way and in some cases already being deployed. So it used to be that we needed to know our base technology. What's a machining center? What's a robot? What's a weld saw? What's a coatings line? Now we need to know smart sensors and smart devices, control systems, connectivity, networking, cybersecurity, network security, and yes, data science, analytics, artificial intelligence, and machine learning. That is a real world example of artificial intelligence in manufacturing. And there are others. There are some in the paint industry. Bob Murphy, who's the Senior Vice President of Change Management for Rockwell Automation, puts it right. He's a friend of mine, and he said it's not about what happened, but what is about to happen and how we can avoid it. That is this new world of artificial intelligence, this new world of machine learning in manufacturing. If you've never spent any time in Fanuc's plant in Rochester Hills, Michigan, it is worth a tour. They have a really, really cool customer experience center. As many of you know, they make tremendous numbers of paint robots. In fact, if I'm correct, they're the only American manufacturer of paint robots in the entire United States. And that's Paul Aiello, their Director of Education, another great friend of mine, standing next to a see-through paint robot, which is really, really kind of cool. You can actually look inside of that thing and see what's going on inside the paint robot. But it's not about what happened on the manufacturing line. It's not about what happened to our paint robot. It's about what is about to happen and how do we avoid it. Let me give you some examples. Fanuc has a technology they call zero downtime. And here was just one example where they detected an abnormal electrostatic operation during production. Obviously, that's a huge issue. It can result in damaging the equipment. It will literally shut down the servo motor on a paint robot if that failure mode is detected. And so it gets really, really expensive. Well, this algorithm basically was tracking the data and realized that there was an increase in current spikes. And so they were able to alert the coder before the equipment was damaged. And the customer, the coder, replaced a fluid delivery line and resumed normal production prior to downtime occurring. Saved 2 hours of downtime on the paint line. Here's another example of an ESTAT check on a paint cable. This was a customer that had deteriorating cable performance. Failure to supply the desired level will affect paint quality and transfer efficiency. So they recognized an anomaly. That sent an alert off to the coating facility. So the customer was alerted. The customer confirmed actually that the cable had gone bad. They went and checked it and replaced it. That example saved 2 hours of downtime and quality issues on the paint line. A third paint example, this is an interesting one, paint excessive rail torque. So they noticed that there was excessive torque on the paint rail. The root cause ended up being a bearing that was beginning to fail. And so the algorithm noted that, alerted the customer, and you can see that the bearing was replaced, the torque is back to normal, estimated downtime avoided, 6 hours. Now I want you to think about why this is important. If we think about a manufacturing operation, let's take an automotive manufacturing operation. I serviced a number of them when I was in my coating career. You know, if you shut down a coating line, that's $250,000 a year in an automotive operation. So if you shut down the line, I'm sorry, $250,000 an hour. If you shut down the line, it can cost them up to $250,000 an hour. 6 hours of downtime is $1.5 million. I want you to think about two coders, one that's using this technology, the other one that isn't, and one shuts down time after time after time and the other one doesn't. Over time, what is going to happen to that coder that isn't implementing this technology? I think we all know the answer to that question, and that's why this is so important. So we need to know the applications. Now here is the other side of that equation, know the applications times two. We need to understand the applications or the platforms that are available to us in implementing artificial intelligence. So there are four categories of these. The first one is programming languages. You're familiar with some of these, C++, Java, Python. And so we certainly need to be familiar with programming languages used in artificial intelligence, but we don't necessarily have to do all of our own programming. We don't have to program from scratch. There are applications frameworks that will give us a huge head start that have already written a lot of the code, and we just need to implement them. So we need to understand what applications frameworks are. We need to understand GPU accelerated libraries. The truth of the matter is artificial intelligence consumes tremendous amounts of computational capacity. And so we need to streamline that as best we can without going into a ton of depth. Basically, GPU and GPU accelerated libraries allow us to process information much more efficiently on our own CPUs, on our own computers, or we can gather our own data, what people in the business call training data, send that up to the cloud, to Amazon Web Services, to Google, have it analyzed there, and then have the data and the output come back down to us. So we need to know these applications as well. So as we're closing out our time here, I have, and this will take a few minutes, but I have 11 predictions for the next 10 years. 11 predictions of what is going to happen in the world of coatings in the next decade. Now, some of these may scare us a little bit, and that's okay. It's better to be scared and ready ourselves than to be blind. And what I'm trying to do here is impress upon us how quickly our world is going to change and how important it is that we get out in front of it. So 10 years from now, I hope the Chemical Coders has me back and we can see how close these predictions were. But here are 11 things that I think are going to happen in coatings in the next 10 years. Number one, autonomous trucks and vehicles will transport product from customers to finishers to lines and back. So we will have autonomous trucks that are driving between manufacturing facilities. They won't have drivers in 10 years. I'm a believer that most of our automobiles won't have drivers either, that most of us will be in autonomous vehicles driving around for wherever it is we're going. 10 years from now, we won't be driving our own cars. But I also believe that that is 100% true. We already have autonomous trucks on the highways, and we will not have drivers in our trucks. We will not have drivers on our forklifts. So in most companies, a lot of companies already are using AGVs, automated guided vehicles, in their manufacturing operations. But all of the product that moves from a facility, a customer's facility, to a finisher's facility, back to the customer's facility, what have you, all of that will be autonomous 10 years from now. Number two, using vision systems, robots will load and unload your racks and parts. We saw how that that classification system that identified the dog could identify the dog. There are vision systems already that are getting pretty good at identifying individual parts, being able to pick up individual parts out of containers, put them on racks. And so we won't have people loading and unloading our coatings line 10 years from now. We will use advanced vision systems, which is another version of artificial intelligence. We talked about, Jay Lee mentioned machine vision in his application of industrial AI that we covered a little while ago. So we will use those vision systems. Robots will load and unload your racks and parts. 10 years from today, using blockchain technology, for those of you who are suppliers to the finishing industry, you will know exactly how much paint, powder, materials to produce, to hold in inventory, and to ship. There will be no waste at all in that supply chain, because you will have predictive analytics coming from your customer, knowing when they're going to run out, and having product arrive at their facility in real time. And that will happen 10 years from now, if not sooner. 10 years from now, because of this, the differentiator between materials and chemical suppliers, so those of you who are suppliers to the finishing industry, is going to be who can best predict your customer's consumption and meet it in real time, because you will be able to drive tremendous amounts of waste out of your customer's operation. They won't have to store inventory. There won't be inventory obsolescence. They won't run out of inventory and have to take their line down. And the differentiator will be those companies that figure out how to measure that, figure out how to exactly meet demand, and the ones that don't. 11 years from now, your customers' MRP systems will tell your MRP systems that parts are on the way. So if you are a custom coder, if you're a contract coder, and you're servicing your customers, there won't be a phone call or a purchase order that says, hey, we're sending the parts over. Your system will know those parts are coming over, because your customer system will tell it. There won't be a human being in the middle of that. It will just be automatic, that the customer system will tell your system that the parts are on the way. And because of that, your coatings lines will literally schedule themselves, optimizing themselves for the best combination of parts, the best line density, the best rack density, the best line speed. Every single variable on a coatings line will be built into an algorithm, and your line will know the parts are coming and will set itself up to run those parts. Your parts, or your coatings lines, will schedule themselves in 10 years. Number 7, titrations, analysis, and material additions will be performed 100% automatically. There won't be a chemist going around the facility, taking samples back to a lab, measuring them, deciding what adds to make, sending out an AVO to your chemical maintenance team to make additions to your tanks and make additions to your processes. All of that will happen automatically. There won't be anybody doing that in the organization in 10 years. Number 8, quality defects will be driven to zero using in-process inspection and digital twins. That digital twin that I showed you at the beginning, that really cool, the paint robot that was being run digitally, we will have digital twins for every single manufacturing operation. In fact, I'm working on a project right now in central Wisconsin where we're putting together an effort to build a digital twin for every single manufacturer in about a 5-county area, believe it or not. And so digital twins are a thing of the future. We'll use in-process inspection vision systems that will measure information, send it back to an AI algorithm that will measure how the process is running, how all the variables are fitting together, and we'll predict quality issues before they ever happen, and will enable us to offset those quality problems. So we will have no quality defects, believe it or not, in 10 years in the world of finishing. Number 9, the differentiator between contract quoters will be those who use AI in Industry 4.0 to minimize costs and thus price. Here's what's going to happen is that the people that use this technology are going to drive tremendous amounts of cost out of their supply chain. When you drive cost out of your model, it's going to be the same as the companies that were adopting lean and adopting continuous improvement. You drive that cost out of your model, and now all of a sudden you're able to compete on price when you have to, and reinvest in your business in huge ways when you don't. And so the differentiator is going to be the people that figure out how to drive all this cost out of their processes using artificial intelligence and Industry 4.0 and machine learning, driving out the cost, becoming way more competitive. And as we drive costs down, proximity to the customer is going to be really important. If everybody's cost is driven down, now the variable is how far do the parts have to travel, and how close the coder is to the point of use is going to become really, really important. The last of our 11 predictions in 10 years is the differentiator among coatings equipment suppliers is who can embed the right smart technology in their systems. Smart sensors, smart devices, artificial intelligence data, embedded intelligence. So how can we embed as much of this intelligence right into the hardware that we're using to manufacture our parts, to coat our parts, to draw that data out of the equipment, to predict failure, to predict quality issues. The companies that figure this out, whether you are a equipment supplier or robot supplier, whatever, wherever you fit into that supply chain, those are the companies that are going to end up way, way ahead. So I promised 45 minutes. It looks like I'm right on target. So let's talk about our 5 things. Number 1, ignore the threat of artificial intelligence at your own peril. This will fundamentally change your operations. And we need to make sure that we see this freight train coming. I'm telling you, the big companies see it, and the small to medium-sized companies are still telling me we don't think this is important. We don't think we need to train our people. That scares me. That scares me for the future of small American manufacturers. We need to get ahead of that. Number 2, who is your AI and data point person? If you don't have an answer to that question, we need to figure out who on our team is going to be responsible for implementing the strategy. Think of artificial intelligence as a lean tool. So we use it to improve our processes. We use it to improve our customer experience. We find the problem and we use AI to fix the problem. We don't start with AI and try to find problems to fix. Number 4, know the language. We threw a lot of things at you: supervised, unsupervised learning, transfer learning, algorithms, industrial AI, artificial intelligence. We need to know the language. We need to know that there were already applications in the world of coatings and manufacturing, lots of them, where we are using artificial intelligence to improve our operations. And I said 5 things. We really have 6. Number 6 is where we will leave it, and that is that the people on the call today need to get started. Congratulations to you for caring enough about this topic to be here. It's really, really important, and we need to get going in every single one of our operations on implementing an artificial intelligence strategy. So with that, Dan, I'm going to hand it back over to you. If we had customer or visitor questions, if we had attendee questions that rolled in, would be more than happy to answer those at this time if I can.
Thanks, Matt. And I'm looking forward to seeing you in March of 2031 to go over those 11 predictions. So I'm looking forward to that.
I'll put it down.
Okay. The first question, where would a finisher start if they're looking to implement AI into their finishing program?
Awesome question. Yeah, awesome question. I would think, Dan, that we kind of look at numbers 2 and 3 that are up on the screen right now. The first one is that we have to have a person responsible for it, right? So if we're going to start implementing AI solutions, somebody has to learn about it. Somebody needs to understand it. I can tell you that we are working with industrial employers all over the Midwest. I mean, big names, and some of them I can share, some of them I can't. But SC Johnson, Greenheck has been really, really involved with us. Ashley Furniture, hugely involved with us. Kohler Company, Sargento, where we have been working on implementing learning programs for their incumbent employees, for the people that are working there now. We also work with all of our technical and community colleges. We work with our universities. So number 1 is identify the person. And if you don't have somebody on staff, find one, train somebody, but you need to identify that person. And then number 2, which is number 3 on our list here, is recognize that it's a lean tool. Find a problem in your operation, find a quality problem, find a throughput problem, find a customer satisfaction problem that we can then gather data and use AI to help us find solutions. That's where I would start.
Okay, and kind of a sub question of that, like, is pre-treatment or like application, are there certain parts of the finishing operation that are more advanced right now that might be easier to start to implement?
Yeah, that's another really good question. I would say probably looking at 2 or 3 things, Dan. The first one is that anybody who is using robotic finishing systems, actually in the paint or powder booth itself, that technology is already, when we say embedded smart tech, it's already on a lot of the paint robots. Probably, I would say most of them, where we have the capability to gather that data off of the robotics technology out of the controller and actually send it up to the cloud and predict future failure now. That technology is available now, and we see a lot of companies that can afford to do it, doing it there. I think the other thing is to look at yield and understand understand failure modes and then drive that back into the process. So if we're looking at final inspection and understanding why parts are being rejected, or maybe look at variation in mill thickness and understand why we have varying mill thickness and where we're wasting powder, those would be two interesting places to get it going. But it's really, you think about the data from a pretreatment system, you think about it from a curing system. I mean, we have all that data is available to us. There's sensors that we can deploy for relatively, in fact, extremely low cost, sometimes under $100 a sensor, to start gathering that data and sending it off to a CPU to analyze it.
Okay. Are there certain redundancies you need to build in, like power, like in the Gulf Coast, there's power outages for a week or more. If you're implementing these type of strategies, should you have redundant power supply?
Yeah, that's another good question. I would say not necessarily any more than you would have in a normal manufacturing operation. So your AI is only going to be as good as your equipment and your data. And obviously we've learned from the what happened in Texas. I'm actually just a little north of Colorado today. They got, in the place I used to race bikes, got dumped on by about 3 feet of snow. But we know that we can have those types of incidents, no question about it. And so redundancy is always good. But I would say not necessarily any more important in AI than it is in any other part of the manufacturing operation.
Okay. Very good. Well, we'll look forward to 10 years from now. And is that podcast available to anybody?
It is. Yeah. Thank you for asking. So yeah, in fact, I would really appreciate it if the people on today, want to follow it wherever you go for your podcast. So it's on Apple Podcasts, it's on Amazon, it's on Google, it's on Spotify. So if you can find it, it's TechEd, TECHED podcast. You'll notice it by the logo up there before, but it's a little blue robot that says TechEd podcast next to it. Some great guests coming up. We're releasing Blake Moret, CEO of Rockwell, here in the next couple of weeks. Nick Pinchuk, who's the CEO of Snap-on, was just phenomenal, just an incredible advocate for American manufacturing. But we've had some pretty high-profile folks on the podcast, and more coming up, talking about all of this technology, and then also how to train for it, which is really a passion of mine, which is, if we're going to ready American manufacturers for the future of this technology, we have to recognize the employer's responsibility to train their own people. And very few companies are investing in that way. And those are the ones, unfortunately, they're going to get gapped a little bit here in the coming years. So I'm happy to chat about that topic with anybody as well.
Okay. How often do those drop, Matt?
Every week, every Tuesday.
Every Tuesday. Very good.
Yep. TechEdPodcast.com too, by the way. So you can go to the website, and it's just TECHED podcast, all one word.com, and you can find them all there as well.
Very good. How many are there?
Well, we've been doing them weekly since January 1st. So I guess we're probably up to middle of March or so. We probably got 13 of them that have been produced or published, and another 5 or 6 that are recorded and are being edited for publication in the next month.
And they're about a half an hour long. What's an average length, Matt?
Yep, but when we try to keep them around 28 minutes, if to kind of match a commute, if you will. That's kind of the magic time in the world of podcasts. It's another goofy thing I managed to learn over the course of the last year. But if we have a guest that is really kind of fascinating and we don't want to edit some stuff out, they can run as long as about 35 to 40 minutes.
Great. Well, thank you so much. I'm going to sign up for that. And I want to tell everybody that the Wisconsin Chemical Coders is going to have their first in-person meeting in about 16 months, April 13th at Scenic View, and we're going to be talking about industrial water treatment with Adam Ratke from Diamond H2O. It'll be our standard dinner meeting. Registration starts at 4. The meeting will start shortly after 5 with dinner integrated with the meeting. So I'm looking forward to seeing everyone there. And please keep an eye out. The Wisconsin Scholarship Committee is going to be posting our application soon, so keep an eye out for that. And we have our golf outing that we'll be promoting starting in May on July 13th. So if there's no further questions, thank you so much, Matt. You did a great job as always. I really appreciate your availability. And
it's great being with you.
If you have a topic that you feel would be important to our group, please reach out. We'd love to have you anytime.
Well, I appreciate the invitation, and we'll keep that in mind. And thanks everybody for having me. It was a pleasure to be back with you.
Thank you very much.